Okay, so what we have for today is LCMs and HCF. HCF meaning the highest common factor, LCM being the lowest common multiple. Now, let me clear this up. This is a common thing. Most people, when comparing the highest common factor and the lowest common multiple, consider highest and lowest as the key words to check. But that's not the key word. The key word to check when comparing HCFs to LCM is factor and multiple. The LCM will always be greater than the highest common factor. Let me say that again. The LCM will always be greater than the highest common factor. And when it's not greater, it's the same. Okay? Cool. So, finding the highest common factor means gathering the factors of numbers. Lowest common multiple, finding the common multiple between a couple of numbers. Okay, now we're going to go into finding the HCF and the LCM of some numbers. Okay? Now, we want to find the HCF and LCM of 4 and 6. So, this is what we do. We take both numbers separately and break them down into a product of prime factors. Okay? So, for 4, it's an even number, so I know 2 is a factor. And the other number that goes with 2 to make 4 is another 2. They're both prime numbers, so I circle them. Okay, now I take 6. 6 is an even number, so I know 2 is a factor. The number that goes with 2 to make 6 is 3. They're both prime numbers, so I circle them. So that means there are no other numbers to break down. Okay, so 4 as a product of prime factors is 2 times 2. Now in this case, we don't bunch it together and say 2 squared. We leave it separate because we want to see all of that. And 6 is 2 times 3. Now from this, we can get our HCFs and LCM. So we get our HCF first. Okay? So what we do is, the HCF is a common factor of the product of prime factors. Okay? So 4 is 2 times 2, 6 is 2 times 3. The common factor between 4 and 6 is a 2. Okay? So our highest common factor is only 2, because there's only one 2 common to 4 and 6. Okay? Now, the LCM can be found 2 ways. Okay? You can either do the HCF times the remaining factors. Now, what do I mean by the remaining factors? I've already decided that my HCF is 2, so the remaining factors are the ones I didn't touch for the HCF, which is 2 and 3. So that ends up being the HCF, which I found is 2, times the remaining numbers in the factor column, which I didn't touch. That's 2 and 3. So 2 times 2 times 3 is 2 times 2, 4. 4 times 3, 12. Okay? That's one way to find the LCM. The other way to find the LCM Okay? Either way, you need the HCF in both. Is to multiply both numbers and divide by the HCF. Okay? So you multiply both numbers and you divide by the HCF. 4 times 6 is 24. HCF is 2. 24 divided by 2, we get an LCM of 12. Okay, pretty straightforward. Now, the next set of numbers we have to check is 15 and 18. So, we take both numbers and we start to break them down. So 15 ends in 5, so it's 5 is a factor. The number that goes with 5 to make 15 is 3. Both of them are prime numbers, so we circle them and stop the breakdown there. 18 on the other hand ends in 8. That's an even number, so 2 is a factor. The number that goes with 2 to make 18, that would be 9. 2 is a prime number, 9 is not. So 3 is a factor of 9. The number that goes with 3 to make 9 is another 3. Both are prime numbers, so we circle them. So all the numbers are circled, we stop there. So 15 as a product of prime numbers is 3 times 5. 18 as a product of prime factors is 2 times 3 times 3. Now, remember, the HCF is the highest common factor. So you check the common factors between 15 here and 18 here when it's broken down into a product of prime factors. Okay? So, the only common number is 3. Just 1. So 3 is the HCF. Now, remember, the last time I showed you 2 methods for finding the LCM. I'm going to be sticking to this one. If you want to use the other one, you can check your answer with the other one. They should both be able to give you the same answer. So I'm going to be sticking to HCF, which is 3, times the remaining factors. So what are the remaining factors? Let's box them up. So on this side we have 5, and on this side we have 1, 2, and we have the other 3. So we have 2 times 3 times 5. Those are the remaining factors. So when we multiply all of that together, we have 3 times 2, 6. 6 times 3, that's 18. 18 times 5, altogether, that's 19. So the HCF is 3, and the LCM is 90. Notice the LCM is bigger than the HCF. Okay? So, once again, we want to find the LCM and the HCF of 24 and 36. First thing we do, we take the first number, 24, try to break it down into a product of prime factors. So, it's an even number, ends in a 4, so 2 is a factor. The number that goes with 2 to make 24 is 12. 2 is a prime number, 12 is not. But 12 ends in 2, so it's an even number. So 2 is a factor. The number that goes with 2 to get 12 is 6. 2 is an even number, and it's also a prime number. So we circle 2. 6 is an even number. It's not a prime number. So 2 is a factor. The number that goes with 2 to make 6 is 3. They're both prime numbers, so we circle them and stop there. So 24 is 2 times 2 times 2 times 3. So I just gathered all the circled numbers. Now, I go to 36. So, ends in an even number of 6. So 2 is a factor. The number that goes with 2 to make 36 is 18. So 2 is a prime number, 18 is not. Now remember, someone else could, instead of 2 and 18, see 6 and 6. Someone else could see 9 and 4. It's all good. I can see 2 and 18 first, so that's what I go with. So 18 is an even number, so 2 is a factor. The number that goes with 2 to make 18 is 9. 2 is a prime number, so we circle that. 9 is not, so a factor of 9 is 3. The number that goes with 3 to make 9 is another 3. They're both prime numbers, so circle that. So, for 36, you gather all the circled numbers. That's 2 times 2 times 3 times 3. Okay? Now, once we do that, the HCF is all about gathering the common factors. So, we go back to 24, there's a 2 here. To 36, there's a 2 here. So 2 is part of the common factors of 24 and 36. We go back again, there's another 2 here. There's another 2 here. So another 2 is a factor. And then we go back, there's no other 2's that are common. But there's a 3 that's common to 24 and 36. So we take that. So the highest common factor of 24 and 36 is 2 times 2, that's 4, times 3, making 12. Okay? Now, remember the LCM. The method I'm using is HCF, okay, times remaining factors. Okay? Okay? So, the HCF is 12. The remaining factors that need to be boxed up on the left, that 2 wasn't chosen, so that's a remaining factor for 24. And for 36, the remaining factor that wasn't chosen was another 3. So that's 12 times 2 times 3. So that's 12 times 2, that's 24, times 3, that is 72. So the HCF is 12 of 24 and 36, and the LCM is 72. Once again, the LCM is bigger than the HCF. Okay? Now, we want to find the HCF and LCM of 26 and 65. Okay? So, first thing we do, we take 26, try to break it down into a product of prime factors. 6 is an even number, so 26, okay, is an even number, so 2 is a factor. Now, so what goes with 2 to make 26? If you don't know, all you have to do is 26 divided by 2, go back to long division, and you will get 13. Now, 13 is a prime number, okay? If you don't know that, go to your prime numbers from 1 to 20, which you should have as a list. You should know that by heart. So, 13 is also a prime number, so we stop. Okay, now we go to 65. Okay, it ends in 5, so 5 is a factor. The number that goes with 5 to make 65. If you don't know that by heart, that's 65 divided by 5. Go through your long division. You should end up with 13. Okay, so 5 is a prime number, so we circle that. 13 is a prime number, so we circle that too. Now, 26 as the product of prime factors is 2 times 13, and 65 as a product of prime factors is 5 times 13. Now, the HCF is the common factors between both breakdowns. So, the common factor of 26 and 65, or the highest common factor, is only 13. Okay, so that's just 13. And the LCM, remember the formula I'm using, it's the HCF times the remaining numbers. Okay, so HCF times the remaining numbers, or the remaining factors. Okay, so my HCF is 13. Now the remaining factors that need to be boxed up are 2 for 26 and 5 from 65. So we go times 2 and times 5. So 13 times 2, that's 26, times 5, that's 130. Or you can just do 2 times 5, which is 10. 13 times 10, same 130. So once again, the HCF is 13, the LCM is 130, making the LCM bigger than the HCF. Okay? Finally, we want to find the HCF and LCM of 60 and 108. Okay, so we know what to do. Take 60, try to break it down into a product of prime factors. So that ends in a 0, so 2 is a factor, 5 is a factor, 10 is a factor. So I'm going to start with 5 being a factor. So we've chosen 5 as our first factor for 60. So the number that goes with 5 to make 60. If you don't know that, 60 divided by 5 will get you that, and that's 12. Now, 5 is a prime number, so we circle that. 12 is not, but it's an even number, so 2 is a factor. And the number that goes with 2 to make 12, that's 6. 2 is a prime number, 6 is not, but 6 is an even number, so 2 is a factor. The number that goes with 2 to make 6, that's 3. Now 2 and 3 are both prime numbers, so we circle those two. So 60 is a product of prime numbers, or prime factors. You can have 2 times 2 times 3 times 5, only picking the circle numbers. Okay, now we go to 108, much bigger, no panic. Now, some people from 108 can see 9 and 12. First thing I see is that it ends in an even number, so 2 is a factor. And so, the number that goes with 2 to make 108, that's 108 divided by 2, that will get you 54. Okay, 2 is a prime number, circle that. 54 is not, but it's an even number, so 2 is a factor. Don't know what goes with 2 to get 54? Carry out 54 divided by 2. That will get you 27. 2 is a prime number, 27 is not. Okay, so I think 9 is a factor of 27. the number that goes with 9 to get 27 is 3. 3 is a prime number. 9 is not. 3 is a factor of 9. Another factor of 9 that goes with 3 to make 9 is another 3. Both those 3's are prime numbers, so we circle them. 408, product of prime factors, we gather all the circled numbers. So 2 times 2 times 3 times 3 times 3. Okay? So, once that is done, I start with my HCF. I gather all the common factors that are common to the breakdown of 60 and 108. So there's a 2 first. So that's 2. There's another 2 common to both of them. So that's another times 2. And there's a 3 common to both of them. That's a times 3. So in this case, the HCF is 2 times 2, which is 4, times 3, which is 12. Okay? And the LCM, I'm using the formula HCF times the remaining factors. Okay? So my HCF is 12. The remaining factors that were not chosen, we box them up, so that's 5. So times 5. And then we go to 108, so there's 3 there. So we go times 3. And there's another 3 that wasn't chosen. So we go times another 3. Okay? So if we put that all together, 12 times 5, that's 60. Times 3, that's 180. Times 3, that's 540. Okay? So the LCM is 540. The HCF is 12. Once again, the LCM is bigger than the HCF. Okay? So that's about it. Break down the numbers, gather the factors, and remember to use the formula. Okay? Thank you very much. You've been listening to the Math Done, and until next time.